Okay, guys, this is Mr. Hayden. This is week 10, I think. Yeah, week 10, Earth Science. What we're going to be doing today is kind of going over the lab to make sure we kind of understand what's going on here. And again, so if you have any questions via the intranet, I'm going to be stepping away for a second, but I'll definitely get back to it when I can, so you guys can be able to participate. All right. So, again, this is what we're doing today. We're doing basically two things. You're going to get double dipping credit. You get the credit for not just coming to the live session, which is the 10 points. You also get one of the bigger labs of the year. This right here is worth 27 points. For some reason, 27 points. This is like half a test. So what's funny to me is that every single year, this is the one that gets done the least. Because it's not that hard, but for some reason, people think it's hard and they don't do it. So you guys showing up today? You did. Good job. All right, so this is the major concept. Just so you know, the essential question for the people on the internet is, I want to know how does bacteria levels in the water affect the oxygen rate in the water? So again, what kind of bacteria level in the water, if it's high or low, how does it affect the water level? I'm sorry, the oxygen level in it as well. All under control and turn me out of the oxygen. Probably like 3 or 4, but if you could do that, it'd be awesome. 4,600. All right. So that's what the essential question I want for you guys at home to learn. We're going to be learning that today. Just so you know, for the lab itself, I'm going to talk about how to actually go over the lab or how to do the lab for the people on the internet. But then I'm going to go ahead and cut you guys loose so you can get that completed. And we're going to go ahead and finish it up here in class for the people who showed up here, okay? So if you use the virtual lab, by the way, in this case, I do think the virtual lab is better than the other lab because sometimes the solutions are stronger or weaker, so there's a lot of problems with it. In this case, you really don't have all those problems. So I'm going to show you how to set it up, how to get the lab going for the people on the internet. So we'll continue that for us, and we'll get going. So here's a question for you. You guys live right here by the lake, right? We're going to talk more about this lake more than that lake. So Canyon Lake, we're going to talk about Elsinore Lake, okay? Question for you. How would you describe it? Say, nasty. And that's okay. When you look at it, if it's perfectly blue, beautiful water, you're like, I really want to jump in that. No, probably not. Because technically it's like a runoff basin more than anything else, okay, so it's not really lake. But I remember in Orange County, we used to like drive past Elsinore when we were going places or whatever, because we drove on the 15 freeway. And we would notice that, especially during the summer, it would smell as we drove by. We called it, like, jokingly, like smell some more, ha ha, because it would smell like dead fish, because fish were dying. Now this is the question, why are the fish dying? Water's too hot, well, it's still picking up last 3 years. So we'll say that. What other things do you think could also factor into this? And at first, faster than you.
The lake.
Lake being polluted, okay?
Lack of oxygen.
What? Did you read the lab or something? You say oxygen level? All right. By the way, all 3 are valid points. Too hot? Yes, it gets hot during the summer, but just so you know, as fish get hot at the surface of the water, at the bottom it typically stays pretty consistently cold, so they would just swim closer to the bottom when they would live there. So it's fine. If you're ever fishing and it's hot out and you know the fish like cold water, you fish towards the center of the lake where you know it's the deepest, because that's where they'll all be. There you go, in case you need to go fishing. Polluted. Now pollution does play a part to this lake because they're allowing 2-stroke oils and they're allowing all this stuff, and yes, oil was an issue, but a bigger part of that was what we brought up, it's the oxygen. What was happening is that there's no like in a lot of lakes and stuff like that, there's like a water river coming into it, like a noticeable river, like pouring into it. Lake also really doesn't have as much of that. It's not like it's like, oh, there it is. It's just the lowest point of the water table. So what's happening is all this air that was in there is being used up by the fish. And once it's used up, they can't breathe. They die. Just like you. If you can't breathe oxygen, you die as well. And so that's what was happening. So now they have aerators, like those things they got that just like kind of pump air through the system. Like literally, they're putting air into the lake to stop that. It's been a lot better. A lot better. And so that's what you do. You hear a fish tank? Fish tank? A fish tank. We get one for my son. So it might count if you have turtles. Kind of. You still have a little bubble in there, so right? Yeah. Little air thing. It's the same thing. What you're doing is you're forcibly putting air into the water so your fish stay alive. If you did not do that, the algae would grow on the side, bacterial level would rise, fish would die every single time. That's the way it is. So, huh?
Maybe that's what
Did you not have an aerator? Yeah, that's what happened. Yeah, you have to get one. You get one for like $5, $10, and you also can't just go and blow into it because you're blowing out more carbon dioxide. You're not actually putting air into it, like oxygen, and so it's not as maybe as effective. Can you check with this stemmer to see if it's printed out in there? All right. So what we're going to be doing today is we're testing that level. What is that level like? Is there a lot of oxygen, or is there a little bit of oxygen? That's what this test actually tells us. And as we start going through, we're going to set it up, and I'll kind of explain what's happening as we set it up. By the way, if you need a piece of paper, if you did not get one, raise your hand. I think you might leave them here, leave them there. Thank you very much. All right. So this lab, we're going to start off by making a mixture of yeast and water. Okay. Do you know what yeast is? The stuff that makes what?
Bread.
Red rice.
What for dough?
But do you know what it is? What is
bacteria?
Bacteria. What is it? Bacteria that basically makes things rise. Yeast also will eat sugar. When you eat sugar, that becomes alcohol. That's how like wines and other things are made. Beers and whatnot. That's how that actually is made. What we're going to do is we're going to use that bacteria. We're going to put it in the little fake vial up there. And on that fake vial, what you're going to see is we're going to add these three regions. Okay. We don't really. And push the wrong button. And then we'll turn the light off, not the actual. Okay. So what we're going to do is we're going to look at those out. We don't even really focus on what the regions are actually made of. We just need to know that each one of them acts as its own region. So we're going to put A, B, and C in. Now the important one is the D. What the D does is it sets the water up to little droplets. For every single drop you put in, that's the parts per like million that there is of oxygen that's there. So, for example, if I have to put in 2, so if I drop 2 in there, and I'm turned blue on me, meaning all the oxygen is now gone. That means that there was two parts per billion of that oxygen left in there that just got finished up. If I have to put 25 or 30 in there, that means that there was more oxygen that needed to be worked out. Okay, and we're going to do that, and we're going to do it one time. And I'm going to show the people on the online how to actually set it up and actually view the lab. Then I'm going to cut them loose to get it completed on their own. And we're going to complete the lab here in person so people who came in and took the time to come in. Okay? So good for you guys. If you online, I'll still show you guys how to set it up. But we definitely want to make sure if you can, try to make it in person for the next one. All right, people on the online, I'm waiting for my projector to start back up. I pushed the wrong button. Okay, so we're going to start setting up and actually how to do this, so you guys know how to do it when you start it up at home, and then we're going to finish it up in person. So what I'm doing is I'm actually going to pick up my spoon. I'm picking up this actual yeast solution, or sorry, yeast in general. I'm making it into a solution of water of 40 milliliters. And what I'm then going to do, I'm going to take my, you have to do it in this order, it's weird, so just bear with me on some of this stuff because you have to do it this way or it won't work. I have to take my little thing right here, I have to fill it up with water, and it pours it out for me, it cleans it, makes sure there's no extra like random bacteria in there. And I'm going to put it back there. There's water that's left in there. Now what I'm doing is I'm going to take some drops of the yeast solution and put it inside of there. And now I basically have a solution of water and bacteria. It's doing its thing. It's starting to eat up some of this oxygen. Now I'm going to add this A in, So I'm going to go ahead and put 5. 5. Put it down. By the way, this is now just showing you the procedure. I apologize for this, but you have to do it or it won't work. So I'm shaking it up, putting it there, taking the top back off. Am I adding my B? Okay. All right. So I put that there, and then I'm going to then shake it up again. Now, right now is basically starting to activate the solution. So I'm going to set the timer. It wants to do a timer for about 2 minutes. Basically now allowing the bacteria to go out and actually do its work, starting to eat up the oxygen. Once I add C, it's primed and ready to go. And at that point, we'll add D, and I will do that procedure. And once I get that done, I'm going to go ahead and let the guys from the online go, so they can go ahead and finish this off on their own, and then we'll complete it here. So just go ahead and stare at this thing for 1 minute and 30 seconds. Wah, wah, wah. Don't fall asleep. All right, keep it going. By the way, I did bring it up to some people here in the class. I'll talk about an extra credit opportunity if you want to do that. If you would like an extra credit opportunity, go ahead and get a piece of paper out and write down what I'm asking you to do. If you don't, then just ignore me completely. In this, it'll make sense. At home, you have these chemicals in a little water testing kit. What I would like you to do is do one of 2 things. You can do both too if you want additional. Is basically take the same jug of water, so a gallon of water you buy at the store for like $1. Shake it up, get the air in there so it's nice and aerated basically, and then pour it into 5 different cups. And name them, day 1, day 2, day 3, day 4, day 5. And then what you can do is then you're going to add each one of these reagents in there, each one of them right away, so is it 5 of each one basically in each one of the cups. And then each day you're going to test how much air is in there by how many drops of D you put in there. So example, when we start showing you this, if it takes 5, you just write down it took 5 drops of reagent D to make the solution turn blue. Then you're done with that day. The next day, do it again. The next day, do it again. The next day, do it again. The next, keep going with that. And the concept I'm trying to hopefully see, because I have a hypothesis myself, is I think that as time goes on, air leaves the system if you leave water just sitting there. Like the air that's in there will make its way to the surface and jump out. Could be right, could be wrong. Depends on if you see a decrease in oxygen over days, that proves that hypothesis. If you see a consistent one, it disproves it. If you see an increase, that's weird for me because it means you're adding oxygen to it. But take pictures of each one of the cups and kind of just and write down your observations that you see and your hypothesis that you have and the conclusions that were based on that each day. If you turn that in, you'll get extra credit. Give me pictures, don't bring in the solution. Yep. Also, someone brought up a good question last class. They said, what happens if it was salt water? Same or different? And I looked at her and said, I have no idea. So someone, if they wanted to do also, or in addition to the salt, just add the exact same amount of salt, maybe 1 cup of salt for 1 gallon or something like that. Mix it in there. Same agitation, shake it up. Do the exact same process of 5 each drops, yada, yada, yada. And see if there is a correlation between fresh water and salt water, if it affects oxygen levels or not. Maybe it does, maybe it doesn't. I don't know. Deal? That's extra credit if you want that, online peeps. If you're listening to this, you're also welcome to that as well. I would say, since it takes about 5 days, and you have pretty much nothing else to do, you probably turn in the week we get back from spring break. So it gives you that spring break week to kind of focus on it if you needed to. Okay, so when we get back from spring break, so the first week in April, that would be due. All right, so I already did A and B. I'm going to go ahead and put C in there. I'm going to go and put my 5 drops. Boom. Put it back in here. Oops. Shaking it. By the way I'm shaking it is I pick it up and I click down on my mouse and I hold it and it shakes it. So in case you care. Now at home, what you would do is based on the parameters of the test, or the lab, you would add 1 drop of this D solution, cap it, and shake it, and count how many drops it takes to turn it blue. As of right now, it's not, it has to be really bleak. It'll make a substantial blue difference. And so that's how you complete this lab for the people at home. So again, remember, I want to know what the essential question is how does the bacteria level, either being high or being low in water, affect the amount of oxygen? So you guys can go ahead and take off, finish up the lab if you like. Remember, there's an extra credit opportunity out there for you to do over break if you choose to do so. Again, I wanted pictures of each one, label each cup. Try to use the same cups. If it was me, I would just use Dixie cups or whatever those red cups are because they're consistently made of the same material, same size. You don't have any type of changes in your experiment. Same water. Everything needs to be the same. Same area. Don't put one in your room, the other one in the hallway, even though it's weird. Don't do that. Or even don't even try to put them, don't even put them outside because then it could be affected by other circumstances, like a bird could poop in it or something like that, and totally ruin all of your experiment. So just make sure you stay pretty consistent with that. So go ahead and have a good rest of the day. I'm going to check, yeah, he's saying, did you know you can break the test tube? Yes, I did. You can break it. I just don't want to do it now because I'd have to start over. You fill the lab out by reading each one of the components. Reading also the study guide will give you what, basically how to do it step by step. Question number 2 is pretty much just an answer. Question number 3 itself is also just an answer. Question 4 is mathematics. Good luck doing that. I've only had 3 people as of today ever get it right. If you're close, I'll still give you credit. But no one, 3 people have gotten it right pretty much ever. It's really hard. And we're going to try to do that in class today. And then number 5 is also pretty straightforward, pretty simple. And number 6, you want to pick a solution or pick different locations. So such as they tell you if you want to use fresh rainwater, you can use a dog bowl, you can use a puddle, you can use a toilet, whatever you want to use to be able to test the oxygen level, you're more than welcome to do so, okay? So have a good rest of your day and take care, and I'm going to go ahead and start kicking people out so I can continue with the lab in person. Huh? Not else going to die. Can you get my power cord? Thanks, man. Thank you for letting me know.